pre-cal, we are back for case 2 of section 7.3. Section 7.3, case 2, what do we do when we have repeated factors in the denominator? So step 1, our setup is similar, but we must include all descending powers of the repeated factor. So once again, setup is the same, but every descending power has to have a representative. So what does that mean? Well, if we have x plus 2 over x times x minus 1 quantity squared, please note that both of these factors are linear. Even though this is to the second power, the factor itself is linear. So that's what I'm talking about there. The setup is the same as I said. We're going to have a over x, b over x minus 1 to the first power, and c over x minus 1 to the second powers. So every descending power of that repeated power has to have a representative. So let's take a look at the problem. So step 2. Same thing, eliminate the denominators by utilizing the LCD. So our least common denominator here is x times x minus 1 quantity squared. So we're going to eliminate the denominators by getting the common denominator all the way across. Please remember that once we have that common denominator all the way across, we are done with the denominators and we do not need them anymore. So step 3, carefully simplify using order of operations, dumping the denominators. So here we go. Obviously, x minus 1 quantity squared gives us x squared minus 2x plus 1. B times x is bx, so bx times x minus 1, and then c times x. I'm continuing on following order of operations and getting everything organized and ready to go. So a times x squared, a times negative 2x, a times 1, bx times x, bx times negative 1, cx. Remember, we want to organize the information. We want to organize the information and set up all the factored parts. So that's what's coming up here. So first thing to remind you of, notice over here on the left, we do not have a quadratic term. If you don't have one, then all you need to do is put in a ghost term to hold its position. So if you don't have a quadratic term, just let it be 0. So organizing the information, use the commutative property here to put together what goes together. So ax squared plus bx minus 2ax minus bx plus cx. Please pay super attention to all of the signs because you don't want to do all this work and then have a careless mistake because you missed a sign. So pay attention to the signs. And then finally here, we're looking to factor. We're looking to factor because what is being multiplied by x squared, a, and b. So take out that a plus b. X squared is the GCF. And we have x squared times a plus b. X times negative 2a, negative b, and a positive c, and then finally the constant a. So after we've done this, and I've got it all color coordinated for you, it allows us to see what the system of equations is here. The system of equations, directly from our last step, I'll show it to you all at once. So, 0 is equal to a plus b. 1 is equal to negative 2a minus b plus c. And then, hooray, 2 is equal to a. So, in this particular problem, we immediately know one of our values for a, b, and c. We know that a is equal to 2. So, from here, let's solve the system. So this is our system. Hooray! Let's use this. So if a equals 2 and a plus b equals 0, then b has to be negative 2. So now we know b, We know A. We're going to use substitution, and I'm showing you here, we're going to take this B value, plug it in here. We're going to take the A value, plug it in here. So 1 minus negative 2 times 2 minus negative 2 plus C. Follow order of operations carefully. There's a negative 4, there's a positive 2. 1 equals negative 4 plus 2 plus C. Negative 4 plus 2 is negative 2. Add 2 to both sides. We see that C is equal to 3. We know A, we know B, we know C. Last step, write the decomposition. To write the decomposition, we're just going to substitute in our A value, B value, and C value into that original decomposed expansion. So x plus 2 over x times x minus 1 squared is equal to A over x, which is 2 over x, plus B over x minus 1. Remember, that was to the first power. So that's negative 2 over x minus 1 plus 3 over x minus 2 quantity squared. So the big idea here is, all the way back to step 1, if the denominator has repeated factors, and you can also see this in our textbook on page 804, the setup is similar, but we must include all descending powers of the repeated factor. That is case number 2.